Welcome to Business Literacy Module 6, Working with Fractions and Decimal Numbers. The first thing we have to ask ourselves is, what is a fraction? Well, a fraction is a part of a whole, and we write it as the fraction over the whole. So if you look at the disk on the right hand side, it is divided into 4 parts. One of the 4 parts is blue and 3 of the 4 parts are green. So when we write the fraction for the blue part, we say that 1 in 4 parts, or 1 over 4 is blue, or we can simply say 1/4 is blue. When we want to write the fraction for the green part of the disk, we say 3 out of 4 parts, or 3/4 are green. And what I want you to notice then there is that 1/4, or 1 part of quarters, plus 3/4, or 3 parts of quarters, is 4/4, or 4 out of 4, and that is the entire thing. So if we have something that is 1 over 1, or 2 over 2, or 3 over 3, or 4 over 4, like in this case, we are talking about the whole thing. Now, when we write a fraction, the part that is above the line is called the numerator, and the number that is below the line is the denominator. And when we nominate something, we know that that is the thing we are talking about. So the numerator tells us how many of the denominator was used, while the denominator is simply the number into which a part is divided. So if we have 17/25, like in this example, what are we talking about? We are talking about 25ths. So that's the denominator. And how many of the 25ths are there? There are 17 25ths. So 17 is the numerator. In the previous slide, I already told you that if we have 2 over 2, or 3 over 3, or 4 over 4, or anything over itself really, we are talking about 1. So the moment we have a million millionths, we only have 1. So there are different ways to write the same number. So 1 can be written as 2 over 2, or 6 over 6, or whatever. Whenever the numerator and the denominator is the same, we are just talking about 1. Now that brings me to the concept of equivalent fractions. And I want you to look at the 3 discs on the left. The disc 1 has 2 parts. One of the 2 parts is blue. So we could say 1/2 is blue. The second disc is divided into 4 parts. But 2 of the 4 parts are now blue. So we can say 2/4 are blue. The last disc has 8 parts. It's divided into 8 slices, like a pizza. And 4 of the 8 parts are blue. So we can say that 4/8 are blue. So notice though that the blue part of all the discs remain exactly the same. The right side is always blue, and the left side remains green, regardless in how many pieces we divide it. And so therefore we can see from the above that 1/2 is exactly the same as 2/4, is exactly the same as 4/8. And so when we have fractions that are the same, we say that these are equivalent fractions. Now we are going to look at how we write equivalent fractions, and I'm going to give you a little bit of the reasoning behind it. Now remember, from what we did in the previous chapter, the multiplying or dividing by 1 doesn't change a number. If we have 3 times 1, it remains 3. If we have a half times 1, it remains a half. If we have any unknown, like x in this case, x times 1 remains x. If we have all the parts of the whole, we have the whole thing. So 2/2 and 3/3 and 4/4 are all the whole thing. So it is that thing. It is 1. Okay, and the same would be the case for x. X over x would also just be 1. So therefore, multiplying or dividing both the numerator, the one at the top, and the denominator, the one at the bottom, with the same number will always give us an equivalent fraction, because what we are in fact doing is just multiplying or dividing by 1. So there I've given you an example. 2/5 multiplied by 4 over 4, or 1, is 8 over 20, and that is because 2 times 4 is 8 and 5 times 4 is 20. When we now take that second fraction, 8/20, and we divide it by 2 over 2, still just 1, we get 8 divided by 2 is 4, and 20 divided by 2 is 10, so we get 4/10. Then if we take that fraction, the 4/10, and we multiply it, in this case by -3 over -3, still just 1, we get -12 over -30, because 4 times -3 is -12, and 10 times -3 is -30. So these are all equivalent fractions, and so therefore we know that 2/5 is equal to 8/20, is equal to 4/10, is equal to -12 over -30. But now, in order to make things simple for us and enable us to actually do the calculations, we want to write a fraction in its simplest form. And what does that mean? Well, writing a fraction in its simplest form means no whole number other than 1 can divide into both the numerator and the denominator. So we know, therefore, that a half is simpler than 2/4 or any other equivalent fraction. Because if you look at 2/4, 2 can divide into 2, and 2 can also divide into 4. So it is not in its simplest form. Okay, so if either the numerator or the denominator is a prime number and cannot be divided into the other, we know that the fraction is in its simplest form. Okay, so 1/3 and 2/3 will therefore both be in their simplest forms, and that is because in both cases here, 3, the denominator, is a prime number. And I'm going to show you what a prime number is just now. But 3 over 6 can be simplified to a half. How? Because we can divide 3 by 3, giving us 1, and we can divide 6 by 3, giving us 2. And then, by the way, 2 again is a prime number. So what is a prime number? A prime number can only be divided by itself and 1. And nothing else. So I've given you there the first 10 prime numbers, and really in this course those are the only ones we will ever use. So the first 10 prime numbers is 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. On this slide, I've given you a couple of simplification tips. So let's look at them. The first one says any even number can be divided by 2. And the number is even if the last unit of that number is a 0, a 2, a 4, 6, or 8. So we take 1112, and when we divide that by 2, we get 556. Notice that the last unit in that number was a 2. But if we have a number like 2221, the last unit, or the last number, or in that last unit rather, in that number is a 1. And so if we divide that by 2, we get 1110 and a half, or another way to write it would be 1110.5, which is not a whole number. The second tip says the following: if the sum of the units in a number is divisible by 3, then the number itself can be divided by 3. So take the example there we have a number 35148. So when we take each unit in that number, 3 plus 5 plus 1 plus 4 plus 8, we get 21. And we know that 21 can be divided by 3, and we will get 7. And so therefore we immediately know that the number 35,148 will also be divisible by 3. And when we take it and we do divide it by 3, we get 11,716. And of course, you'll just use your calculator for all of these. The third tip says, if the last unit in a number is a 5 or a 0, then the number can be divided by 5. And I've given you two examples there. The first one, 12,345. We can divide that by 5, and then we get 2,469. Or if we have 12,340, we can divide that by 5, and of course that will give us just one less, 2,468. Now, knowing that, take the following example. I want you to look at a number like 45 over 75. Now, if we use the rules that I've just given you, it is clear that both numbers can be divided by 5 as well as 3. And now we get the fourth tip. It says, if a number can be divided by two prime numbers, then it can also be divided by the product of those two numbers. So, because both 45 and 75 can be divided by 5 and 3, we can say that 3 times 5 is 15. And so now we know that 45 over 75 can be divided by 15 over 15, and that'll give us 3 over 5, and that is the fraction in its simplest form. Now, of course, if you know your tables, then the simplification is much easier. Okay, so if you have 32 over 48, now you could look at that and say both those numbers are clearly divisible by 2 because they are both even numbers. But if you know your tables, you will know that both are multiples of 8. 8 times 4 is 32, and 8 times 6 is 48. So immediately we can divide both the numerator and the denominator by 8. And then if we do that, we will get 4/6, or 4/6 rather. And because both 4 and 6 are still even numbers, they can be further divided by 2. And if we divide both that numerator and denominator by 2, it's now expressed in its simplest form, which is 2/3. Okay. Second technique that we can use here to make simplification quicker and easier is to use cross-elimination when we multiply fractions. So take the two fractions there, 5/8 and 4/10. We now can cross-eliminate because 5 goes into itself 1 and it goes into 10 2 times, while 4 goes into itself 1 and it goes into 8 2 times. So what do we have at the now on the one side we have a half, 1 over 2, and on the other side we also have 1 over 2, so we can say 1/2 multiplied by 1/2 is a quarter. How did I get that? 1 times 1 is 1, and 2 times 2 is 4.